Hello everyone. Our today's topic for the chemistry 9701 AS level is the enthalpy change of formation from enthalpy change of combustion. We have to develop first the enthalpy cycle. Enthalpy cycle for such type of the conversion, calculation of the enthalpy change of formation from enthalpy change of combustion. We have to write down the element first, and we have to put oxygen that reacts with elements to form the product, and these products then again react with oxygen or burn in oxygen and finally give the combustion product. Now this is an indirect route, but if elements react with oxygen and directly change into the combustion product, this will be a direct route. During the direct route, the standard enthalpy change might be considered as delta H naught 1. For the indirect route, enthalpy change might be considered as delta H naught 2. Now, this will be the standard enthalpy change of formation. Now, if we want to find out this standard enthalpy change of formation, remember always subtract this indirect route enthalpy from direct route enthalpy. The formula will become as delta H naught 1 minus delta H naught 2. This will be the final formula which can be used to find out the enthalpy change of formation of from the enthalpy change of combustion. Now, if I write down here, if I take say ethanol is my combustion product, say C2H5OH. Now, first of all, I have to write down the balanced chemical equation for the reaction. Enthalpy change of combustion, delta H naught F. Right, graphite, hydrogen. Now, for example, if I take graphite here, carbon, 2 mole of carbon, then we have to C2H5, 3 moles of hydrogen, and then I have to take 1 mole of oxygen. Now, this is elements present in the standard states. If all of these burn in oxygen separate, the product might be formed first, that can be considered as C2H5OH, and then this will burn to give the combustion product. That combustion product will be CO2 plus water. Now, as 2 carbon are there, Now, 4 oxygen is here and 1 oxygen is here, 5 oxygen is here, but how many hydrogen? Hydrogen are the 6. It means that 3 moles of water will form, and how many oxygen now? The oxygen will have 3 oxygen, this and 4, 7, and we have to take 3 moles of oxygen here because the 1 oxygen is already present in alcohol. Now, this is the overall equation, and these are the elements. Now, these elements one by one can be converted into this carbon dioxide, and then here the oxygen will also be 3 moles of oxygen. They will produce. Now we have to just put the values. What are the formation? What are the values of combustion of carbon? Combustion of carbon or graphite will be say, for example, combustion of carbon is minus 393.5 kilojoules per mole. Now it multiplied by 2. Then plus how many hydrogen? 3 moles of water formation. Hydrogen, for example, minus 285.8 kilojoule per mole. Now these are the two values which will be utilized here. Now if the enthalpy change of combustion is given as minus 1367, if it is minus 1367.2 kilojoule per mole, we can use all these values to find out this delta H naught F. Now delta H naught F is the same here. I will write the delta H1 value here, and I will subtract this value from these. We will get minus and again minus yes, and then I will subtract this value from 1367.2. Now if I add both of these, 4 point now this will become plus 13. What will be the answer? The answer will become 2.323. This will be the answer. This much amount of energy, delta H naught F will be formation of alcohol. On the similar manner, the second is enthalpy change of hydration of an anhydrous salt. Now, there are some salts in which they contain water of crystallization, just like CuSO4 contains 5 moles of water, magnesium sulfate contains 7 moles of water, calcium sulfate contains 2 moles of water. Similarly, sodium sulfate Na2S2O3 contains 5H2O. Now all of these are called as hydrates because they contain water crystallization. But if we heat all of these water molecules will be evaporated out, and then we will get anhydrous salt. Now anhydrous salts are those without water crystallization. If we put water and then convert the anhydrous salt into hydrated salt, and this process will definitely enthalpy change will take place. That will be called as an enthalpy change of hydration. Now both hydrated salt and anhydrous salts are dissolved into sufficient amount of solvents to prepare a very dilute solution. Whenever we will do this, definitely the enthalpy change will take place when anhydrous salt will be dissolved, and the different enthalpy change will take place when hydrated salts will be dissolved in sufficient large quantity of the solvent. And that's why definitely once again we have to subtract the indirect enthalpy values from the direct enthalpy values. And now I have written these values for the sodium thiosulfate taken from the example from book. Now this is my anhydrous salt Na2S2O3 plus water H2O, 5 water. This is anhydrous salt. On adding water, we get a hydrated salt. How hydrated salt will be represented? That will be represented by the dot. Na2S2O3 dot 5H2O. This is now hydrated salt. Now hydrated salt will be dissolved into sufficient quantity of water, and this will automatically become very dilute solution of Na2S2O3 aqueous. Now, if I want to calculate the delta H naught hydration for the sodium sulfur, what I have to do? We have to subtract this indirect value from the direct value. This will become minus 7.6, and then on subtracting minus 47.4 kilojoule per mole, we will get the answer. What? We will get the answer is equal to 0.55, then 5. This will become 55 kilojoule per mole. That will be called as an enthalpy change of hydration for this reaction. In this manner, using Hess's law, we can develop enthalpy cycles for the formation from combustion and from the enthalpy change of hydration by dissolving anhydrous and hydrated salt in the large quantity of the solvents to make a very dilute solution. I thank you all.